I found 3 regular expressions. Regular expressions are a powerful tool for various kinds of string manipulations. They are a domain-specific language, or DSL, that is present as a library in most modern programming languages, not just Python. They are useful for 2 main tasks: verifying that strings match a pattern, for instance, that a string has the format of an email address, and performing substitutions in a string, such as changing all American spellings to British ones. Domain-specific languages are highly specialized mini-programming languages. Regular expressions are a popular example, and SQL for database manipulation is another. Private domain-specific languages are often used for specific industrial purposes. Which of the following tasks cannot be performed using regular expressions? Checking whether an email address is real? Can't do that. Changing the URL part of an email address, you can do, and checking whether an email address is of the correct format, you can do that as well. Regular expressions in Python can be accessed using the re module, which is part of the standard library. After you've defined a regular expression, the re.match function can be used to determine whether it matches at the beginning of a string. If it does, match returns an object representing the match. If not, it returns none. To avoid any confusion while working with regular expressions, we would use raw strings such as R followed by the string in double quotes. Raw strings don't escape anything, which makes use of regular expressions easier. For example, import re, pattern equals R followed by the string spam. If re.match, parentheses pattern, comma the string spam, 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 colon print the string match, else colon print the string no match. We have the pattern of spam, and the string that we're comparing it to is spam, spam, spam. And re.match looks for it to be matching at the beginning of the string. So it does, spam in the string and spam in the pattern. So we will print out the string match. The above example checks if the pattern spam matches the string and matches match if it does. Here, the pattern is a simple word, but there are various characters which would have special meaning when they're used in a regular expression. Which of these patterns would not re.match the string spam, spam, spam? Remember, the .match portion is looking at the beginning of the string. So pam, spam would not match because the beginning of the string starts with S. Pam starts with P. Spam, spam would work and SP would work, but not the first one. Other functions to match patterns are re.search and re.findAll. The function re.search finds a match of a pattern anywhere in the string. The function re.findAll returns a list of all substrings that match the pattern. Example, import re, pattern equals R followed by the string spam. If re.match, parentheses pattern, comma, the string egg spam sausage spam, colon print the string match, else colon print the string no match. Okay, so we're using re.match in this first if-else condition, and since the string starts with EGG, which is egg, and the pattern is SPAM, which is spam, they don't match because re.match looks at the beginning of the string. That's why if you look down at the result, the first line of output is no match. The second if condition, if re.search, now we're using search, not match, but search, parentheses pattern, comma, the string egg spam sausage spam, colon print the string match, else colon print the string no match. Search looks for the string anywhere, looks for the pattern anywhere in the string, not just the beginning. So we will get the output of match. Finally, we have print, parentheses, re.findAll. So now you get to see how findAll works. Parentheses, pattern, comma, the string, egg, spam, sausage, spam. Well, the pattern is spam, and it looks for every occurrence of spam. It looks for every occurrence of the pattern spam in the string, egg, spam, sausage, spam. There's 2 spams in there, so our output is a list. and because it's a list, it's going to be contained in straight brackets, and because we are dealing with strings here, the output is going to be in a string as well. So you have it in straight brackets for a list, spam in single quotes, comma, spam in single quotes, which means there are 2 occurrences of spam found. In the example above, the match function did not match the pattern as it looks at the beginning of the string. The search function found a match in the string. The function ReadOut does the same thing as ReadOut except it returns an iterator rather than a list. Which of these is not a function in the Re module? Find list. You do have find all, and you do have ReadOut find all. You do have ReadOut search. You do not have ReadOut find list. The regex search returns an object with several methods that give details about it. These methods include group, which returns the string matched, start and end, which returns the start and ending positions of the first match, and span, which returns the start and ending positions of the first match as a tuple. So here's our example. Import re, pattern equals r, the string Pam, match equals ReadOut parentheses pattern, comma, the string egg, spam, sausage. If match, colon, and then we have 4 different printouts if there's a match. Print parentheses match.group, empty parentheses, and if you go down to the result, you'll see that using match.group gives you the string that was located in the pattern that was located in the string, which is Pam, so it shows you Pam. The next print command says print parentheses math.start, empty parentheses, and what that does is it gives you a 4. And if you look at egg, spam, sausage and you start counting from 0, the E would be 0, the first G would be 1, the second G would be 2, the third spot would be the S, the 4th spot would be the P for Pam, and that's the beginning of the pattern, the 4th position in the string. The next print command says print parentheses match.end, and that's going to take you to 7. Now watch this, because 7 is not the M in Pam. 7 is actually the S in sausage. So it takes you to position. All right, and the last one, print parentheses match.span, empty parentheses, gives us a tuple that includes both the start and the end of the position of the pattern found. So here we have 4, 7. Drag and drop from the options below to print the starting and ending positions of the match. So we start off with import re, short for regular expression, pattern equals r, followed by the string test, match equals ReadOut parentheses pattern, comma, the string sum test, print parentheses match.start, and print parentheses match.end. Search and replace. One of the most important re methods that use regular expressions is sub. The syntax is re.sub, parentheses pattern, comma, REPL, short for replace, comma, string, comma, max equals 0. This method replaces all occurrences of the pattern in string with REPL, substituting all occurrences unless max provided. This method returns the modified string. So here's the example. Import re, str equals the string my name is David. Hi, David. Pattern equals r followed by the string David. New string shortened into new str equals re.sub, parentheses pattern, comma, the string Amy, comma, str, which is the variable that holds the original string. Lastly, we have print parentheses new string shortened as new str, and as you can see in the result below, my name is Amy. Hi, Amy. So we've replaced David with Amy. Fill in the blanks to replace all 9s in the string with 0s. Import re num equals the string 07987549836. Pattern equals r followed by the string 9. Num equals re.sub, because we're going to make a substitution here, parentheses pattern, comma, here's where we're going to put the substitution, 0, and we are going to put the substitution in what? We're going to put it in the variable num, which is containing the string that we're dealing with. Finally, we have the print command that's going to print out the value of num. Simple MetaCharacters. MetaCharacters are what make regular expressions more powerful than normal string methods. They allow you to create regular expressions to represent concepts like one or more repetitions of a vowel. The existence of MetaCharacters poses a problem if you want to create a regular expression, or regex, that matches a literal MetaCharacter such as the dollar symbol. You can do this by escaping the MetaCharacters by putting a backslash in front of them. However, this can cause problems since backslash also have an escaping function in normal Python strings. This can mean putting 3 or 4 backslashes in a row to do all that escaping. To avoid this, you can use a raw string, which is a normal string with an R in front of it. We saw usage of raw strings in the previous lesson. Fill in the blanks to create a raw string. str equals, and before the string enclosed in the double quotes, we just put the letter R to stand for raw. The first MetaCharacter that we will look at is the dot. This matches any character other than a new line. For example, import re, pattern equals R, followed by the string gr.y. If ReadOut parentheses pattern, comma, the string gray, spelled grey, colon, print the string match 1. So the pattern is gr.y, dot, anything, any letter or character except for new line can replace that dot. So grey will be a match. So we will see in the result the line that says match 1. The next if condition, if read.match, parentheses pattern, comma, the string spelled gray, that's going to be also a match because the dot will replace the E or the A. So you also see in the result match 2. But when we get down to the third if condition, if read.match, parentheses pattern, comma, the string blue, print match 3, no. Nowhere, in no way, in no shape, in no form does blue match the pattern gr.y. What would quote dot 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 quote match? It would be any 4-character string with no new lines. The next 2 MetaCharacters are caret and $. These match the start and end of the string respectively. For our example, we have import re, pattern equals R, followed by the string caret gr.y $. If re.match, parentheses pattern, comma, the string gray, spelled with an E, print the string match 1. Well, as you can see, it's basically the same as the thing we just did. The only thing that's different is we have a caret for the beginning and a $sign for the end. Otherwise, it's working the same, and so we will see match 1. The second one, if re.match, parentheses pattern, comma, the string gray, spelled with an A, again, same thing as last time. So the caret and the $sign actually didn't change anything other than let you know that that's telling you that's the beginning and ending of the string of the pattern they're looking for. So match 2 is also a winner. But the last one, if re.match, parentheses pattern, comma, the string stingray, we do not get a match there because we've used the caret to indicate the pattern has to start with G. And this string starts with S. So because of that, it's not going to allow this to be a match because it's specifying that the beginning of it has to be the G. Therefore, that won't work. The pattern string caret gr.y $sign means that the string should start with gr, then follow with any character except a new line and end with y. So it's very specific. It doesn't just mean it's looking for a match somewhere inside the string. It has to begin like this and end like that. Fill in the blanks to create a pattern that matches strings that contain 3 characters, out of which the last character is an exclamation mark. They've already given us the R for raw. They've already given us the double quotes for the string. They've also already given us the ending $sign. So we want 1 dot for the first character, another dot for the second character, an exclamation point for the third character, and the $sign means that's the ending. Alrighty. Character classes. Character classes provide a way to match only one of a specific set of characters. Listen to that again. A way to match only one of a specific set of characters. A character class is created by putting the characters it matches inside square brackets. So here we have import re, pattern equals R, followed by the string, and here's the character class. It's in brackets, kind of like a list, A-E-I-O-U. So we're looking for vowels. All right, so then we have three if conditions. If re.search, parentheses pattern, comma, the string, gray, print match 1. So we're just looking for any of those. You don't have to have A-E-I-O-U, all of them. It's in a character class, so as long as any one of them matches the string, you've got a match. So when you look down there at the bottom, you see the result, you see the line match 1 because the E matched the E in the character class, so you're good. The next if condition, if re.search, parentheses pattern, comma, the string QWERTYUIOP, print match 2. Looking down at the result, print match 2 actually printed out because you matched the E, you matched the U, you matched the I, and you matched the O. So you're looking for vowels and you found vowels. So you get to print out that string. Now in the last if condition, if re.search, parentheses pattern, comma, rhythm myths is the string, we will not print out match 3 because even though we have vowels, they're Y's, and Y was not put in our character class, only A, E, I, O, and U. So that's not a match. The pattern, A, E, I, O, U, in straight brackets in the search function matches all strings that contain any one of the characters defined. What would character class ABC, character class DEF match? Either ABC or DEF. Any letter out of ABC, then any letter out of DEF. That's the right one. Character classes can also match ranges of characters. Some examples would be the character class A to Z, which matches any lowercase alphabetical character. The class capital G to capital P, which matches any uppercase character from G to P. The class 0 to 9, which matches any digit. Multiple ranges can also be included in one class. For example, capital A to capital Z, lowercase a to lowercase z. Both of those are included in one character class, square brackets, and it matches a letter of any case. Notice also that you do not use commas. A to Z are right next to each other. For this example, import re, pattern equals R, followed by the string, character class capital A to capital Z, character class capital A to capital Z, character class 0 to 9. So here we have three if conditions. If re.search, parentheses pattern, comma, the string capital L, capital S, capital 8 will print, if that's true, it will print match 1. And as you can see in the result, it does print match 1 because capital A satisfies the first character class, the capital A to capital Z. Capital S satisfies the second character class, which is another capital A to capital Z, and the 8 fulfills the third character class, which is a digit from 0 to 9. The next if condition, if re.search, parentheses pattern, comma, the string capital E3, colon print the string match 2, that's not going to work because you have to satisfy all three character classes, and this is only satisfying 2, so that won't work. Last if condition, if re.search, parentheses pattern, comma, the string 1 lowercase a lowercase b. That's not satisfying the order of the conditions or the constraints. The order 0 through 9 would be the third character, so the 1 would have to be the third, and the lowercase a and lowercase b does not satisfy the constraint of needing to be capital letters. So that entire thing is wrong, so therefore you will not see the output of match 3. The pattern in the example above matches strings that contain 2 alphabetic uppercase letters followed by a digit. It's very specific constraint there that we've used in this regular expression. What would character class 1 through 5, character class 0 through 9 match? 10, 19, 50, or 90? Any two-digit number from 10 to 59. That's a better answer right there. Place a caret at the start of a character class to invert it. This causes it to match any character other than the ones included. So it's basically like saying not. Other meta characters such as $sign and dot have no meaning inside of character classes. The meta character caret has no meaning unless it is the first character in that class inside of the square brackets, okay? So here's our example for that. Import re, pattern equals R followed by the string, character class, caret, again, it's the first thing in the class. So that's kind of like if you can think of that as not, capital A to capital Z. So we have three conditions here that tests this. If ReadOut search parentheses pattern, comma, the string, this is all quiet, print match 1. This will work because this is all quiet happens to be characters that are not capital letters, so that works. The next if condition tests if ReadOut search parentheses pattern, comma, the string capital A lowercase b, capital C lowercase d, capital E lowercase f, capital G 1 2 3, print match 2. The reason this will work is because it finds parts of the string that are not capital letters. So the parts that it's finding are the lowercase letters and the digits. So we get to see match 2. The third if condition is if ReadOut search parentheses pattern, comma, the string, this is all shouting. Everything is in caps. This is what we're trying to avoid, not capital letters. So because there's nothing in that string but capital letters, we will not print match 3. It's not matching the constraint that we've created with our regular expression. The pattern character class caret, which like I said, if you think of that as meaning not in this instance, capital A to capital Z excludes uppercase strings. Note that the caret should be inside the brackets to invert the character class. So it's got to be inside the brackets and first. Fill in the blanks to match strings that are not entirely composed of digits. Import re, pattern equals R, and then in the double quotes we start off with a square bracket to indicate our character class. And because we want it to be not digits, we want to use the character symbol first inside that square bracket. And it's that little, looks like a little pointing up. So the caret 0 through 9, closing straight bracket, and close the whole thing up with the string, double quote. And the last line they gave us, and that's M equals re.search parentheses pattern, comma, the string, hi there. More MetaCharacters. Some more MetaCharacters are the asterisk, the plus sign, the question mark, and the curly braces. These specify numbers of repetitions. The MetaCharacter asterisk means 0 or more repetitions of the previous thing. It tries to match as many repetitions as possible. The previous thing can be a single character, a class, or a group of characters in parentheses. And here's our example. Import re, pattern equals R followed by the string egg, and then the group spam followed by an asterisk. If re.match parentheses pattern, the string egg, then print match 1. This will work. You see at the bottom, result says match 1. The reason this will work is because we're using re.match, which means we're going to look at the pattern and the beginning of the string. And as long as the beginning of the string matches the pattern, we're good. Egg and egg. It's good enough. If re.match parentheses pattern, also, let me go back up. Spam, because spam is grouped in parentheses and an asterisk is following spam. The asterisk means 0 or more repetitions of that. And in the first example, egg doesn't have spam, but that's okay because the asterisk says that the condition can be 0 or more of that spam group. Okay, so on to the second if condition. If re.match parentheses pattern, comma, the string egg, spam, spam, egg, print match 2. This also works, as you can see down in the result. You see match 2 is output because it starts off with egg. The pattern starts off with egg and the string starts off with egg. And here we actually have 2 spams, and you can have 0 or more spams. So that works fine for that match as well. But when we get to the if ReadOut parentheses pattern, comma, the string spam, print match 3 does not show up in the result because, again, we're using the dot match, which means that our pattern has to match the beginning of the string, and our pattern starts with EGG. Our string is SPAM. They don't match. If we used ReadOut search, that would probably work, but the ReadOut match won't. The example above matches strings that start with egg and follow with 0 or more spams. What would character class A caret followed by an asterisk match? Okay, well, the caret is not first, so we're not going to invert the A. So it's looking for 0 or more lowercase a's or carets. It could be either of them. So 0 or more repetitions of lowercase a or caret would be the answer for that. That would be the match. The MetaCharacter Plus is very similar to asterisk, except that it means 1 or more repetitions as opposed to 0 or more repetitions. So here's the example for that. Import re, pattern equals r, followed by the string g plus. If re.match parentheses pattern, the string g, print match 1. That works because g plus means 1 or more g's, and this the string is a g, so it's good to go. So in the result, you see match 1. In the second if condition, we have if re.match parentheses pattern, comma, a whole string of g's. Print match 2 will also show up in the results because g plus means 1 or more. It doesn't say how many more. It could be a million more. So we get match 2. The last if condition is if re.match parentheses pattern, the string ABC. Well, what knucklehead would think that that matches? It matches not at all. So of course, print match 3 is not going to show up in the results. To summarize, asterisk matches 0 or more occurrences of the preceding expression, and plus matches 1 or more occurrences of the preceding expression. Fill in the blanks to create a pattern that matches strings that contain 1 or more 42s. They already gave us the R for raw. They already gave us the double quotes for the string. We have 42 grouped in parentheses. Now, do you remember which one it is? Is it the asterisk or is it the plus that will give us 1 or more? It's the plus. And the dollar sign indicates that this is to be the end. All right. The MetaCharacter question mark means 0 or 1 repetitions. Import re, pattern equals r, followed by the string ice. In parentheses, we've got the group of a single dash, followed by a question mark, and then the word cream. The question mark is only dealing with what's directly in front of it, which is the group dash. So question mark means 0 or 1. So our pattern is ice cream without a dash or ice cream with 1 dash. Nothing else will match. We've got 4 if conditions. Let's check out each one. If re.match parentheses pattern, the string ice cream with 1 dash, you see the match 1 shows up in the result because that fits the constraint that we've created. If re.match parentheses pattern, comma, ice cream with no dash, that also fits the constraint because a question mark means 1 dash or 0 dashes. So you also see match 2 showing in the result. The third one, if re.match parentheses pattern, the string sausages, that is like so not even close to matching. So of course match 3 will not output. And if re.match parentheses pattern, the string ice dash dash ice, that also does not obey the constraint because the question mark means only 0 or 1 dash. All right, next, fill in the blanks to match both color and color. These two spellings of color are different. Pattern equals R, and in the string of the double quote string, we have COLO. We want to group U because we may or may not want to use it. And we want 0 or 1 occurrences of this, so we put a question mark afterwards followed by an R. So this way our match will be COLOR or COLOUR. Curly braces can be used to represent the number of repetitions between two numbers. The reg x in curly braces x comma y means between x and y repetitions of something. Hence, in curly braces 0 comma 1, that's the same thing as the question mark, since the question mark lets you have 0 or 1 repetitions of whatever is preceding it. If the first number is missing in this curly brace 0 comma 1 or 2 comma 5 scenario, if the first number is missing, it's taken to be 0. If the second number is missing, it is taken to be infinity. For example, import re, pattern equals R followed by the string 9, and then in our curly braces we have 1 comma 3, and then the dollar sign to indicate the end. So we are looking at a pattern that contains specifically anywhere between 1 to 3 nines. That's what we're specifically looking for. So let's look at the if conditions and talk about the output. If ReadOut parentheses, pattern, comma, the string 9, print match 1, that works. Because 1 9 is good. We're looking from anywhere between 1 to 3 nines. The second if condition, if ReadOut parentheses, pattern, comma, the string 999, which is 3, that also matches our constraint, so print match 2 is in the result as well. But when we try if ReadOut parentheses, pattern, comma, the string with 4 nines there, the match 3 will not print out because we've went outside of the boundaries of our constraint. Our regular expression is identifying that we only care about 1 to 3 nines, and that's all that we're trying to match. So that will not go. And then it shows again at the bottom in double quotes 9, and then in the curly braces 1 comma 3 dollar sign matches string that have 1 to 3 nines. And I think too that dollar sign is important as well. If the dollar sign wasn't there indicating the end of the string, it probably would output match 3. But saying 1 to 3 nines and that's it means that showing a fourth nine would be a problem. So I think that's why the dollar sign is important in that instance. Which of these is the same as the MetaCharacter Plus? Remember what the MetaCharacter Plus stands for. It stands for 1 or more. So in our curly braces, 0 comma means 0 or more, so we don't want that one. The bottom one that is in curly braces, 0 comma 1, that means 0 or 1. We don't want 0 or 1, that would be the question mark. We want the one in the middle, the curly braces that is 1 comma and then nothing at the end. So that goes from 1 to infinity, 1 or more. That's what we're looking for. That is the same thing as the plus symbol. Okay, I think now we will go on to groups. After that, we have special sequences, email extraction, and then the Module 8 quiz. All right, on to groups. A group can be created by surrounding part of a regular expression with parentheses. This means that a group can be given as an argument to metacharacters such as the asterisk and the question mark. Here's the example here. Import re, pattern equals R followed by the string egg. We've got the group spam and an asterisk. So this is like review. If ReadOut parentheses pattern comma the string egg, then print match 1. If you look down, you see match 1 does output. The second one, if ReadOut parentheses pattern, the string egg spam 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 egg, print match 2. If you look down, you see match 2 actually does output. So that was a match as well. And the third one, if ReadOut parentheses pattern, parentheses, the string spam, print match 3, the reason that didn't work is, again, we're using the match And match means we're looking at the beginning of the string, and the pattern starts with egg. Egg does not match spam, so that does not follow the constraint we're looking for. So spam in parentheses represents a group in the example pattern shown above. What would, and this is a kind of a long string, and the string is indicated by single quotes here instead of double quotes, which is fine. Inside that string, we have a group because you see the parentheses, and inside that group, we have 3 character classes as defined by the square brackets. So in the first character class, we have a caret being the first symbol inside of it, which means we're going to invert whatever's in there, A, E, I, O, U. So that means not A, E, I, O, or U. So the first character has to be not a vowel, at least not one of those vowels. The second character class has to be one of those vowels. It has to be one of the vowels included in there, so why would not fit that constraint? And then the third character has to be not a vowel again. And then after the parentheses, we see the plus symbol, which means we want to see that pattern of not a vowel, vowel, not a vowel, at least one time, if not more. So, with that being said, our answer is not nothing. Our answer is not a number of repetitions of A, E, I, O, U that's a multiple of 3. Our answer would be 1 or more repetitions of a non-vowel, a vowel, and a non-vowel. The content of groups in a match can be accessed using the group function. A call of group parentheses 0 or group with nothing in the parentheses returns the whole match. A call of group parentheses n, where n is greater than 0, returns the nth group from the left. The method groups, plural, with nothing in parentheses, returns all groups up from 1. Here's an example. Import re, pattern equals r, followed by the string a, the group bc, the group de, the group fgh, and nested inside the group fgh, you have the group g by itself, and finally the letter I. That's the entire string. Match equals readout match, parentheses pattern, comma, the string A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. If match, colon, now we've got 5 different printouts so that you can see how group with nothing in parentheses, group with a 0 in parentheses, group with a 1 in the parentheses, group with a 2 in parentheses, and how groups, how all those different forms work to give you a different output. The first one being print parentheses match dot group with nothing inside. The pattern, if you look, goes A, B, C, D, E, F, G, H, I. So A through I. So the result is A, B, C, D, E, F, G, H, I. The second print parentheses match dot group with a 0 inside, is like the same thing as group with nothing inside, so you get the same output there. The third print command is print parentheses math dot group with a 1 inside. That wants you to find, starting from the left, the first group, the first thing in parentheses. And the first thing in parentheses is the B and the C. So that's why you see BC as the output. The fourth print command says print match.group parentheses 2. So you're going to look for the second group, which is the DE. So that's why the DE is the output. The very last print command is print parentheses match.groups, plural, with nothing in there. That wants you to name all the groups. So starting from the left to the right, and also this is going to be output in like a tuple. It's in parentheses. It's giving you the group of groups, if you will. So in one set of parentheses, you have BC, which is your first group, DE, which is your second group, FGH, which is your third group, but remember you also have G nested inside by itself, so then you have the G by itself as the fourth group. Alright, and each of those are separated by commas and delineated as well in their own single quotes. As you can see from the example above, groups can be nested, as the G was nested as a group by itself inside the FGH group. What would group 3 be of a match of 1, parentheses 23, parentheses 4, 5, 6, 7, 8 with an inner parenthesis of 5, 6, a 9, and then parentheses 0. We're looking for group 3, starting from the left to the right. The first group would be 23. The second group would be 4, 5, 6, 7, 8. The third group would be the nested 56. There are several kinds of special groups. 2 useful ones are named groups and non-capturing groups. Named groups have the format parentheses, question mark, capital P, name in tags like that, and then ... where name is the name of the group and ... is the content. They behave exactly the same as normal groups, except that they can be accessed by group parentheses name in addition to its number. Like when we were looking before, what was group parentheses 3? You can also do group parentheses the name, whatever's in those tags, to also access it. Then there's the non-capturing groups, and they have the format in parentheses question mark colon ... They are not accessible by the group method, so they can be added to an existing regular expression without breaking the numbering. And this you have to look at a couple of times to digest it, but this is the example. Import re, pattern equals R, followed by the string, which is in double quotes. You've got here 2 groups. The first one is a named group, the second one is a non-capturing group, and the third one is just a group. It's not a named group or a non-capturing. So the named group looks like this. Question in the parentheses, question mark, capital P. In the tag symbols there you have the word first, and then the ABC is what the contents are. That's what the ... was representing in the syntax. The second group you have is the non-capturing group, and it's identified in the parentheses by the question mark and the colon, and the content of this non-capturing group is DEF. The last group is just your regular old group, and it's in parentheses GHI. Next we have match equals ReadOut parentheses pattern, comma, the string ABCDEFGHI. If match, colon, print, parentheses match.group, parentheses the string first. That print command will give us, if you look down in the result, ABC. The reason it gives us ABC as the result is if you look up and you see the word first in those tags, you're using print match.group parentheses first to identify that particular group, which happens to have the contents of ABC to the right of the name. That's why ABC is there. The second print command, print parentheses match.groups, wants us to identify all the groups, but it's not going to identify the non-capturing group because the non-capturing group is not accessible by the group method. So we'll see all the other ones but that. Because we're seeing multiple groups, the output is in parentheses, and each group is sectioned off in double quotes and separated by comma. So you see the ABC, the contents of the first group, ABC. The second group with the question mark and colon, DEF, that's just being skipped over because it's identified as a non-capturing group with that question mark and colon, and it bounces straight to the very last group, which is GHI. All right. What would be the result of len, which is short for length, parentheses, match.groups. So we're going to count the length of all of the groups, except for non-capturing groups, of a match of, and here is a bunch of groups. A is the first group. The second group is BC, but you have C by itself as a nested group, and by the way, it's also a non-capturing group because the question mark colon, so we actually won't count that one. D would actually be the third group. A would be the first group, BC would be the second group, C by itself is not counted, D would be the third group, and E has a question mark and a colon before it too, so that's also not counted as a group. So I say we have 3 groups here, A, B, C, and D. I'm going with 3. Let's see if I'm right. And I am. Another important MetaCharacter is that pipe symbol. This means or. So red, pipe symbol blue, red or blue, matches either red or blue. For example, import re, pattern equals R followed by the string GR, and then in the group A or E, Y. Match equals re.match, parentheses pattern, comma, the string gray spelled with an A. If match, print match 1. Well, that's going to give us print match 1 because in the group A or E, we're using A. Before we were using this gray and gray, 2 different spellings with a dot, and it worked both either way, but you could put other letters as well. You could put a T in there and there would be a match. This way you're being more specific that the user can only pick an A or an E, not anything. Like the dot will let you put anything in there and it'll be a match. The second is match equals re.match, parentheses pattern, comma, gray with the spelling with the E. If match, print match 2. And for the same reason that A worked, E will also work because the condition is A or E. So we see also match 2 in the result. The third, match equals re.match, parentheses pattern dot griy. That's not going to fly because we have to choose between A or E for the spelling, so the I is not going to do it. If we had gr.y, that would have worked, but we're not using it that way. We've got a different constraint here. If match, print match 3 will not show up. What regex is not equivalent to the others? The first group is 1 or 3 or 4 or 5. Now 1 or 2 or 3 or 4 or 5 in the grouping, which is the parentheses. And then we have in the straight brackets, we have a character class. So the character class is one of any of those, 1 or 2 or 3 or 4 or 5. So the top 2 are the same. The thing at the bottom, 1 through 6, that's not the same. That's not the same as the top 2. Special sequences. Okay, special sequences. There are various special sequences that you can use in regular expressions. They are written as a backslash followed by another character. One useful special sequence is a backslash and a number between 1 and 99. For example, \1 or \17. This matches the expression of the group of that number. This matches the expression of the group of that number. So let's look at that. Import re, pattern equals R followed by the string, the group dot plus. So dot plus means 1 or more of any character except for new line. The \1 means you're going to repeat the first group. In this case, there's only one group, so you're going to repeat whatever that is, whatever represents 1 or more dots. And the dot can be replaced by any character except for new line. All right, so then match equals re.match, parentheses pattern, comma, the string word, space, word. If match, print match 1. Well, as you can see down in the result, match 1 did output, and the reason is WORD will represent, can be represented by dot plus. At least one character, and there's no limit to how many. The \1 basically repeats whatever the first thing did. So since word satisfied the group dot plus, the \1 just repeats it. The second match equals re.match, parentheses pattern, and in string you have question mark, exclamation, space, question mark, exclamation. If match, print match 2. Well, the same thing. The dot can be represented by letters. It could also be represented by symbols. So we get to also see match 2 displayed. Now, match 3 is match equals readout match parentheses pattern, comma, the string ABC space CDE. Well, that's not going to fly, and we are not going to see match 3 printed out because our constraint means we're going to get a repetition of what is preceding. And so we would have to see ABC space ABC in order for match 3 to be an output. Now, note that the string, the group dot plus backslash 1, is not the same as the group dot plus, the group dot plus, because backslash 1 refers to the first group's subexpression, which is the matched expression itself, and not the regex pattern. What would the group ABC or XYZ backslash 1 match? Now, in the group, which is in the parentheses, you have ABC or XYZ, and then you're going to duplicate that. The backslash 1 is going to duplicate that. So I see the middle one as being the answer. It's the string ABC or the string XYZ followed by the same thing. More useful special sequences are backslash D, backslash S, and backslash W. These match digits, white space, and word characters respectively. In ASCII mode, they are equivalent to the group 0 to 9, the group backslash T, backslash N, backslash R, backslash F, and backslash Z, and the group lowercase a to Z, uppercase a to Z, 0 to 9. And then there's an underscore after that 0 to 9. In Unicode mode, they match certain other characters as well. For instance, backslash W matches letters with accents. Versions of these special sequences with uppercase letters, and they're showing you backslash uppercase D, backslash uppercase S, and backslash uppercase W mean the opposite to the lowercase versions. For instance, backslash capital D matches anything that isn't a digit. So that's kind of similar to what the caret did. It's kind of like saying not. Okay, so import pattern equals R followed by the string, the group backslash capital D, which means not digit, plus backslash D, which means digit. Match equals read.match, parentheses pattern, comma the string hi, 999, exclamation point. If match, print match 1. The result is showing match 1. So hi is a non-digit. So that represented the backslash capital D. H and I are non-digits. The space would be the concatenation of the digits, and you have a backslash D for digits. It's not indicating repetition, it's just indicating non-digits plus digits, and that's what we got. The second, match equals read.match, parentheses pattern, comma, the string 1, comma 23, comma 456. If match, print match 2. That doesn't match. It doesn't match. And it doesn't match because it starts off with a digit, and our constraint says that this needs to start off with a non-digit. Now also, if we look down at the third match, match equals read.match, parentheses pattern, comma the string. In the double quotes, we have a space, then we have an exclamation point, a space, a $sign, and a question mark. If match, print match 3. Well, match 3 is not printing out because, let's see why. Probably because a non-digit I guess a space is a non-digit, but I guess we need to use something referring to the space one way or the other. I don't know exactly how to explain it. I'm not sure if it's because of the space. But in any event, match 3 doesn't fly. The group \D plus \lowercase d matches one or more non-digits followed by a digit. And that's basically the rule. One or more non-digits followed by a digit. And I guess a space is not considered a non-digit. Which pattern would not match the string 1, 2, 3 exclamation, 4, 5, 6 exclamation? What would not match? Let's see. What's our pattern? We've got a character class 1 through 6 exclamation. I think that the character class would have to be 1, 2, 3, 4, 5, 6 exclamation. I think that's how it would have to be identified in the square brackets in order for that to fit. I think that 1-6 exclamation, if that's a character class, that could be read as 1 or -6 or exclamation point. And that would not fit our pattern. The second one is saying you've got a group there with a plus sign outside of the group, so it means one or more of \D means digit. The asterisk after D means 0 or more digits, followed by \W means not a word. Not a word. And the last one means we've got a group with \D, which means not a digit. So we can't go with the first one. We can't go with the third one because this actually starts off with a digit. So the \D, not a digit. This middle one has to be it, I'm thinking. And I'm wrong. Great. Okay, let's just unlock it to make this video go by quicker. Surprisingly this works. The group \D, which means not a digit, plus \S question mark. Question mark means 0 or 1. \S I thought meant spaces. I'm sorry. I read the... I'm trying to match the pattern. I read the question wrong. What would match the pattern? But the question is, what would not match the pattern? So therefore, the first and second one would match the pattern. So I was wrong when I said 1-6 exclamation wouldn't work. Obviously, that would work. I guess 1-6 doesn't mean 1-6 exclamation. It means the range 1 through 6 or exclamation. So I was completely wrong in my interpretation. In the character class straight brackets, 1-6 exclamation means that could match the pattern. And the second one, \D, means one or more digits. \W means not a word. So I'm going to say that I misunderstood all of those. And I misunderstood the question. So there we go. Additional special sequences are backslash capital A, backslash capital Z, and backslash lowercase b. The sequences backslash capital A and backslash capital Z match the beginning and end of a string respectively. The sequence backslash lowercase b matches the empty string between the backslash W, which means a word, and backslash capital W, which means not a word, or backslash lowercase w, which means a word, characters, and the beginning or end of the string. Informally, it represents the boundary between words. The sequence backslash capital B matches the empty string anywhere else. Import re, pattern equals R, followed by the string backslash B, which stands for border, word border, and then the group cat, and then backslash B, which means another word border. Match equals ReadOut parentheses pattern parentheses the string the cat sat. If match, print match 1. Well, we see at the bottom match 1 did print, so if we look at the word cat in the pattern, there's a space before the C and a space after the T, so I guess they're considering those as borders. So the backslash B on either side of the group cat, I guess the space is considered a border. The second, match equals ReadOut parentheses pattern. We have another string. We scattered. But again, we have a symbol before the C and a symbol after the T. I guess they're considering those borders of cat as well, because match 2 is also displaying. The third one, match equals ReadOut parentheses pattern parentheses we scattered. If match, print match 3. Well, match 3 is not showing up, and I'm thinking that they are considering the S on one side of the cat and the T on the other side of the cat. They're not considering other letters as being borders at all. So if there's a letter before or after the group cat, then that's not going to be considered borders. So therefore, it's not matching the constraint of our regular expression. At the bottom, it says the string backslash B, the group cat backslash B basically matches the word cat surrounded by word boundaries, not surrounded by other letters or other words, but by word boundaries. Which pattern would match the string spam with an exclamation point in a search? Okay, let's try not to be confused. The backslash A and the backslash Z are supposed to be the beginning and end. I see no exclamation point in the first one, so I'm going to say the first one's wrong. The second one is an S and a P with a backslash A, which is supposed to indicate the beginning, an M and a exclamation point, and then the backslash Z, which is supposed to be the ending. So because the backslash A is supposed to mean the beginning, I'm going to think the middle one shouldn't be it either. The bottom one is a backslash A to indicate the beginning. The backslash Z indicates the ending. The S, capital S, represents the S. The dot, dot, dot could represent any character. So that could represent the P, the A, and the M. The backslash B represents a border after the M. And then a dot, which could represent the exclamation point. So since after the M we don't have another letter, we have that exclamation symbol, I'm going to think that might be the winner. And I guessed correctly. Alright, we did special sequences. We're now down to email extraction, and next will be the quiz. To demonstrate a sample usage of regular expressions, let's create a program to extract email addresses from a string. Suppose we have a text that contains an email address. str equals the string. Please contact info@sololearn.com for assistance. Our goal is to extract the substring info@sololearn.com. A basic email address consists of a word and may include dots or dashes. This is followed by the @ and the domain name, the name, a dot, and the domain name suffix. This is the basis for building our regular expression. Pattern equals R followed by the string, and here I can identify one group in parentheses, the @ symbol, a second group in parentheses, and a third group in parentheses. So let's read this off group by group, starting with the leftmost group. The leftmost parentheses has a character class, which is represented by the straight brackets. Inside of the character class, there's a \W, which means word. Then there's a \dot and a dash. So we have a word followed by a dot or a dash. Outside of the character class, we have a plus sign, which means there will be one or more repetitions of the word dot or word dash. Then after that grouping, we have an @ symbol, followed by another group. The second group has a character class, which is represented by the straight brackets, and it does the exact same thing the first one did. A \W, which means a word, a \dot dash, so you can have, after the @ symbol, you can have a word with a dot or a word with a dash. The plus symbol outside of the square brackets, which is the character class, lets you know that there may be one or more of those patterns. And then the very last grouping in the parentheses, you have a \dot, so you're looking for a dot. And then you have a character class, which is shown as what's inside of the straight brackets, \W, which means word, \dot, and you have a plus after that. That means there'll be one or more of that pattern. Okay, so let's read the note that they said. The character class, which is what's in the straight brackets, \W, \dot dash, with a plus afterwards, matches one or more word character, dot, or dash. The regex above says that the string should contain a word with dots and dashes allowed, followed by the @ sign, then another similar word, then a dot and another word. Our regex contains 3 groups. Number 1 is the first part of the email address. Number 2 is the domain name without the suffix. And number 3 is the domain suffix. Which of these must be done with regular expressions rather than string methods? Checking whether a particular character is in a string, splitting a string, or checking to see if a string contains a date. Which of these must be done with regular expressions instead of string methods? Checking to see if a string contains a date? Okay, that was kind of a guess, as you can tell by the tone of my voice. All right, putting it all together for our email extraction. Import re, pattern equals R followed by the string, group, character class \W \dot dash, outside of the character class a plus symbol, outside of the first group an @ symbol. The second group, which is the parentheses, we have a character class, which is the straight brackets, which houses \W \dot dash. Outside of the character class, that is the straight brackets, we have a plus symbol, which means one or more of those. The third group in parentheses has a \dot followed by a character class in straight brackets, which is a \W \dot. Outside of the character class brackets, we have the plus symbol. And then you finish that whole thing off with the closing double quote. So now the string is done. So that's the first line. The second line is str equals the string. Please contact info@sololearn.com for assistance. After that, we have match equals re.search, parenthesis, pattern, comma, str, if match, print parentheses match.group. And the result is the extraction of the pattern for the email address. The regular expression gave us the pattern to look for. It identified the pattern and extracted only the pattern that we were looking for and ignored all the rest of the string. In case the string contains multiple email addresses, we could use the re.findAll method instead of re.search to extract all email addresses. So if this was a big long paragraph that had multiple sentences with multiple email addresses, using re.findAll would give us the output of all of them. The regex in this example is for demonstration purposes only. A much more complex regex is required to fully validate an email address. In our example, why is the dot character preceded by a backslash? To treat it as a character, it is mandatory, or because it is inside square brackets. To treat it as a character. Okay, now we're down to our Module 8 quiz. Which of these MetaCharacters isn't to do with repetition? The plus sign means 1 or more. The asterisk means 0 or more, so I'm going to go with the backslash. How many groups are in the regex? A, B, C, D, E, F, G. A, B is the first group. Wow. C, D, E, F is the second group. D, E, F is the third group. E is the fourth group. And G is the fifth group. Which regex would match email@domain.com? All right. The first one is a character class 0 through 9. That's not going to work because we don't start this off with a digit. We're starting it off with a word. So that first one won't work. The second one, email \A and then domain \W plus, that's not going to do the trick either. We have no indicators for a dot at all. Let's see, the last one is \W, which means a word or words at domain.com. It seems like that's too easy. I have a funny feeling it's wrong and I just misinterpreted the first two, but I'm going to go with the last one. Oh, good. I'm great. All right, which string would be matched by the string? We have the, let's see, what do you call that character group? Character set? In the straight brackets, 0, 1, so that could be 0 or 1. You could match 0 or 1 or more times because there's a plus after it. A character class. In the straight brackets, it's called a character class. So all the different digits or letters or digits that you put in there need to be a match, at least one of them or more. The plus symbol to the right of that means at least one or more times, then followed by a 0. So 0, and then with a $sign, that means that the 0 should be the end. The 0 should definitely be the end. So since the first example, a 1 is at the end, and the second example, a 1 is at the end, I'm going to go with the third example because $sign means that that's the end, and the other two end with 1s. What would be matched by the string? Let's see. Let's look at the parentheses group. because after the group we have a \1, which means whatever pattern the group in parentheses is, the \1 is going to duplicate it. I think I'm reading that right. But see, then in the answers, I don't see anything duplicated. Let's see, how can I figure this out? 4 in the group, in the parenthesis group, we have a 4. And then in the curly braces, we have a 5, 6. I thought that was the repetition. Oh, I got it. That is the repetition. You're going to have a 4 5 or 6 times, and then the \1 is going to replicate that. So you're going to have a 4 5 or 6 times, followed by a 4 5 or 6 times. If you add those together, you would have a 4 10 or 12 times. This might be guessing silly, but I'm going to guess 10 or 12 4s. Oh, good job. And that is it for regular expressions. The next video will be on something called Pythonicness and packaging, and then I'll finally have my Python 3 certificate.